Welcome back. I am Peace Okechukwu. Owasanya, taking anatomy and physiology of the cardiovascular system. We're looking at conducting system of the heart today. And of course, we've talked about the parts of the heart. I don't know if you still remember them, but I'd really love you to follow suit to our level. So here's the base. I have the apex, the cardiac corpus. Okay, so this is the right part of the heart and the left part of the heart. So we have a right atrium, right atrium, right ventricle, left atrium, left ventricle. Okay, so here is a superior vena cava and inferior vena cava. Okay, and of course we have our valves, the tricuspid valve, mitral valve, bicuspid valve, the seminal valve, aorta, pulmonary trunk, ascending aorta, pulmonary veins, pulmonary arteries. Okay, so there. We've also talked about the structure of the heart, where we made mention of the pericardium, the myocardium, and the endocardium. Yeah. So we'll be concentrating more on the myocardium. That's where the contracting force lies, of course. Okay, so the heart is capable of beating on its own. It's not under the control of any nervous or hormonal influence, kind of. It doesn't need them to start beating. It's true they influence them, because that's where the confusion lies. Okay, if this one doesn't happen, so how come? But that's where the confusion lies. This is what happens, that these things does not cause the heart to beat, but they actually influence the heart, maybe to beat faster or to beat lower. I think I've cleared that part. Okay, so now some group of specialized cells in the heart actually set the pace. They actually start this beating as a result of depolarization and repolarization. And this group of this mass of cells is called the SA node, which is located at the atrium, the right atrium, at the opening of the SVC. So we have it somewhere here. I'd like to use my red marker for that. Okay, so if we have something like this here. Yeah, so this is my SA node. Sinoatrial node, also called the pacemaker. Another term that tends to get students confused is depolarization and repolarization. This is gaining and losing of charge. Most of the cells around in the myocardium, they tend to only depolarize when the cells close to them have done this. But in the case of the SA node and some other, they depolarize on their own. They don't need a closed cell to help them. So that's why they tend to be the pacemaker of the heart, the pacemaker of the heart. So the SA node actually does this at around 80 to 90 times per minute. So you can imagine how fast that is. Okay, from the SA node, this depolarizes and sends the electrical impulses to another group or mass of specialized tissue called the AV node, atrioventricular node, which is somewhere here. And this does not just happen. So this is the nerve impulses going to the left atrium. And then to the AV node. Okay, so this depolarization causes contraction in the right and the left atrium. This contraction will result to the ejection of blood into the ventricle, the total ejection of blood into the ventricle. You know, the major reason for this contraction is to complete ventricular filling, and then the ventricle to eject blood into the pulmonary trunk and the aorta. So SA node has sent these electrical impulses to the AV node, and the left atrium, there is contraction, ejecting blood into the left ventricle. Okay, so the AV node, what the AV node does is now would kind of hold this signal for about 0.1 seconds. Okay, if we had to say, why would the AV node delay this electrical impulses for about 0 to 1 second? Okay, imagine that the atrium, the right and left atrium, is contracting along together, like together with the ventricles as well. You see that the movement of blood will not be synchronized, it will not be coordinated. Blood will just be going haphazardly. So there is need for that delay. You get, there is need for that delay. That's little delay. It's 0.1 seconds. Okay, the AV node, some call it the collecting node, because it's the only pathway, the only channel for electrical impulses to pass from the atrium to the ventricle. Reason, this part is electrically resistant because of the rings, because of the fibrous rings. They are electrically resistant. They can't allow electricity to pass through it. So if they would have, then there would have been no need for the AV node. Impulses would have just gone vim to the right ventricle and the left ventricle. So it has to pass through the AV node. The AV node will collect these impulses, 0.1 seconds, then send it to another mass of fibers called the bundle of His. This kind of splits into two branches. To the left, the right and the left bundle branches. So there's the right, there's the left bundle branches. And then into tinier branches. Called the Purkinje fibers. Okay, so this channel allows for electrical impulses to get to the apex of the heart where contraction tends to start. So our contraction starts from the apex of the heart, pushing the blood towards the pulmonary trunk and the aorta. So that's it with the conducting system of the heart. I want to believe you must have grabbed one or two. You really understood it. The SA node, AV node, bundle of His, the left bundle branch, and the right bundle branch. So that's it. And we'll be looking at other things as well. But for now, thank you very much and God bless you.